how do you convert a repeating decimal into a rational number? In other words, how do you write repeating decimals as fractions? This is one of the coolest tricks I know, and I think I didn't really learn it until I was teaching this class. This is another one of those disappointments where when I learned it as an adult, I felt cheated that I hadn't learned it as a kid. So I'm excited to teach this little trick to you guys because it does come in pretty useful when you can't use a calculator. So we're going to do a little math magic here, and I'm going to show you how we can write repeating decimals as fractions. Because we talked about how to write decimals as fractions, but what do you do when the top never stops, when it repeats? So we're going to start off with an example where the repetend, the repeating block, is just one digit, just a one-digit repetend. So 0.4 repeating, so 0.44444. I'm going to name him. I'm going to call him n. And I'm going to write down this statement, n equals 0.44444 repeating. Okay, so I'm just making a statement there. That's what I'm calling n, the number. If I want to move my decimal past one block of the repeating numbers, if it's only one digit, I just need to move my decimal one place. So how do you move your decimal one place? You multiply by 10. If you want to move the decimal two places, you multiply by 100. If you want to move the decimal three places, you multiply by 1,000. So I'm wanting to do a little math magic here, so I just want to move this decimal over one place, so I'm going to multiply by 10. And if I take this number and I multiply it by 10, it's going to move the decimal there and make it 4.444444. And that's what 10 times my number is. So both of these statements that I have written are true statements. N is equal to this number, and 10 times n is equal to this number. And the reason I wanted to come up with two equations is because I want to use these two equations and combine them and solve them. And you can add and subtract equations if you want to. I'm going to subtract the 10n equation minus the n equation. So if I have 10 n's and you take away one of the n's, I'm left with 9. So I have 9n on the left side. And if I take 4 point all these 4's minus all of the 4's, all of this repeating part is going to fall off, and you're just going to be left with 4. And that I can solve really easily. You just have to divide by 9. And so what do we suddenly have? We have that the number n is 4/9. So 0.44444, where the 4 repeats, can be written as a fraction as 4/9. So we are trying to develop a pattern here, so I'm going to write these over on the side. So you see how the 4, it was the part that repeated, and you see how it ended up in the numerator? There's your repeating block. It ends up in the numerator. But what's in the denominator? It's not a 10, it's a 9. It's not a 10, it's a 9. You can't have a 10 underneath here because 10 is 2 times 5. And that goes back to that rule we learned about how a decimal will terminate if you have only 2's and or 5's in the prime factorization of the denominator. 9 is 3 times 3. So see, we know this is not going to be a terminating decimal. It's going to have a repeating pattern, and the repeating block is what's on the top. So 4/9, that's how you would write 0.4 repeating as a decimal, or as a fraction, excuse me. So let's try one where the repetend is 2 digits. So 0.3636363636. So I'm just naming him. N is 0.363636. I just put an obnoxious number of 3 6's. Well, I want to move my decimal past that repeating block, which means I need to move it 2 places. So I'm going to multiply by 100. If I take n times 100, it's going to move this decimal 2 places. And I'm going to get 36.36363636. And I'm going to play the same game. I'm going to subtract them. And I'll get 99n on the left. And all those 3 6's that repeat past the decimal are going to cancel. We're just going to get 36. And how do you solve that? You divide by 99. So we get n equals 36 over 99. So if you want to write the repeating decimal 0.36 repeating as a fraction, You write it over 99. So what was the repeating block? 36. What ended up in the numerator? 36. Did we fill in underneath with hundreds? No. 99. Let's try one more. We'll see if you can figure out the pattern before I show it to you. So the next one, the repetend is 3 digits. 245, 245, 245, 245. So n equals all these 245s repeating. Now I want to move that decimal past the repeating block, so that's 3 places, so I have to multiply by 1,000. And that moves the decimal past that first repeating block. And maybe, since you've seen this before, you'll understand what's about to happen. 1,000 minus 1 is 999. All these repeating parts at the end cancel, and you get 245. Divide, divide, n equals 245 over 999. So 0.245 repeating. The repeating block goes in the top, and underneath you get 9s. So do you see what the pattern is? If the repetend is 1 digit, 4 9s. 2 digits, 36 over 99. 3 digits, 245 over 999. The pattern you want to pick up on here is how many 9s. However many digits your repetend contains, in this case 1 digit, you fill in underneath it with 1 9. If there's 2 numbers, you fill in underneath it with 2 9s. 3 numbers, 3 9s. That's the pattern. So once you know the pattern and you memorize the pattern, you don't have to do any of this math anymore. You can just go straight to the pattern. So this is absolutely something that you want to memorize for sure. I always test on it. So if you have point A repeating, I just use a letter, 1 digit repetend, it'll be A over 9. If you have 2 numbers, AB repeating, AB over 99. If you have ABC repeating, it's over 999. If you have ABCD repeating, it's over 9999. See that? And these fractions do not have decimals in them. That's the whole point, is we're removing the decimals completely, and we're just getting whole numbers in our fractions. But that's the pattern, and that's the trick. So now we know 1/9, that's a repeating pattern, right? Because there's a 9 underneath, and what's the thing that's repeating? The 1. So that's why this was 0.1 repeating. And that's also why 0.2 repeating turned into 2, fill in with a 9. And 0.3 repeating, 3, that's your repeating block, fill in with a 9 underneath. So see, that pattern works. So if we had like 0.6124, and that was the repeating block, you take the repeating block and you just fill in underneath with 9s, and it is the simplest thing ever if you know the trick. But you watched the video, so now you know the trick.